Why do people go bald?
Why are baboons' bums red?
What's a light year? Why do leaves go brown in the autumn? Why do monkeys like bananas? Why do some things glow in the dark? Why do animals not understand you? Why do my receipts fade after a year?
Don't know the answer? Ask the Naked Scientists.
Hello and welcome to this week's Ask the Naked Scientists with me, Sue Marchant, and Dave Ansell. Daniel has said, we've got some sensor lights outside our house so we can see the lock in the door at night. I've always wondered about the science of these lights, and what's got me is how do they know when to turn on? How does the sensor detect activity?
I think basically these things, I don't know if you ever looked at them closely. If you look at they've sort of got a part of a cylinder looking out the front, which is actually the sensor, where the sensor is. And it's sort of split up into a load of sections. I think at the back of each of those sections there's a sensor which detects infrared light, which is a form of light sort of beyond the red in the spectrum. There's the actual forms of light which we can see. The visible light is only a minute fraction of all the different kinds of lights out there in the electromagnetic spectrum. Beyond the blue side, you get ultraviolet light, which is what makes your clothes glow if you're in a club. And beyond that, you get X-rays, which can take pictures of you. And beyond the red side, you get this infrared light. And I think basically there's a sensor behind each of these little sections, and then some electronics inside, which looks at how bright each of these sections are. And even if it's quite dark, I think even if it's quite dark, there's still enough infrared light for it to be able to get some kind of signal. And if any one of these sections kind of changes quickly, especially compared to its neighbours, then the sensor thinks, there's something going on, there's something in the scene in front of me which is changing, I'll turn the light on. So it's basically looking for changes in a very, very low resolution picture of what it's looking at in the brightness of this infrared light. It's a bit like having a TV camera pointing at something, and it's looking at the view, and if the view changes, it thinks something's happened, I'll turn the light on.
Clever stuff. Foxy from Offley, near Luton, wants to know why when you cough you seem to see stars.
I'm not a doctor, but I can give you my best shot. The retina, which is a bit of the back of your eye, that does the sensing, is actually one of the most energy-intensive parts of your body. So it eats glucose, it eats energy all the time. And so if you do anything which slightly reduces the amount of oxygen, to get energy, you need oxygen and sugar. And those are reacted in all sorts of clever biochemistry, which goes on inside the cells, which I'm not qualified to talk about. So you need both oxygen and sugar. And so if you do anything which means you're short of, especially oxygen, because that's what you get short of quickest, then the retina starts to behave slightly strangely and strange things going on. And I thought if you start coughing too much, you probably start to get slightly short of oxygen. And so the retina at the back of your eyes starts behaving oddly and sending strange signals to your brain. And you see odd things going on. I know I get strange patterns on my eyes if I do too much exercise.
Valerie is on the line. Hello, Valerie.
Hello there, both of you.
Hello.
You're through to Dr. Dave. What's your question?
The thing is that when you're asleep and you waken in the morning and you recover for 5 minutes or so, then when you get up and stand up, you start yawning, which you haven't done when you're lying down in bed. And I'm baffled why this is.
Good question. I do that as well.
Question. I don't know. I mean, again, it's the problem with humans. They're horribly complicated. So again, I'm probably guessing, but I think one of the things which triggers you to yawn is if you're starting to get a bit short of oxygen, because it kind of makes your lungs expand and you kind of take a big lungful of air. So it could be that when you're lying down, you're not actually using very much oxygen, your body doesn't need it particularly. And then when you stand up, all of a sudden, your heart's got to pump faster and all sorts of other things are going on. So that could be one thing that's doing it. Or it could be some strange... The problem I have with bodies is it's very hard to kind of extrapolate from some knowledge to others because there's always something else more complicated going on. But that's one thing which it might be.
Thank you for solving the problem for me. Bye-bye.
Bye-bye. We've got Alan on the line from Orpington. Hello, Alan.
Hello, Sue.
Hello there. What's your question?
It's about tears. We have tears in our eyes,
Yeah,
and there's a logic that is there, obviously, for to moisten the eyes and to keep them sort of free of dust and washing them all the time. But we also cry, and so we've got tears to demonstrate our emotions. Where are the tears? How do they arrive at the eye from other parts of the body? They usually, if you taste them, they're salty. And the other final thing is, do other creatures have tears for the same showing of emotion?
The way that tears are made, I think they're basically blood which has had all of the big bits sort of strained out of it. It's like if passing blood through a sieve. So it stops all of the cells, all the big things like cells and antibodies getting out. So it's a very, 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 very fine sieve. And so that squeezes through, basically. So what's left in the blood is water and a bit of salt, various salts in there. So inside the tear duct there's basically a very fine sieve, and it can kind of open it up and sort of sieve out the blood, and you get sort of water coming through. I think it adds a few other things in there which are quite good at killing bacteria, which is part of the reason why you don't get infections in your eye all the time, because otherwise it'd be quite a nice place for bacteria to live. So there's also some sort of antibacterial stuff going on.
Oh, that would be continuous. If you kept crying and crying and crying, your body would keep supplying enough tears
until you got seriously dehydrated. If you get very dehydrated,
a demonstration to other human beings, or is there a purpose within your own body for that?
The reason I think most animals cry is if they get something in their eye, if they get dust in their eye or something, it basically clears out the eye. If you get bacteria in the eye, then eyes will stream. If you get something in your eyes, like if you cut an onion, then you get some quite nasty chemicals coming out of that, which are slightly poisonous and make your eyes hurt. So the reason why you might start crying then is your eyes trying to wash them out and keep the surface nice and clean. Why you cry for emotional reasons? I'm guessing that it's probably one of these kind of evolutionary things, that if you're kind of upset kind of physically, but if you're in sort of your facial region you quite often cry. Again, this is me guessing because I'm a physicist, I'm afraid. So if there's a physical thing which means you're upset, so other people come and help you, so this is like millions of years ago. So if one hominid started crying, there was obviously something wrong with their eyes, so they'd go and help them out. Yeah. And then possibly that sort of somehow over millions of years got slightly confused with kind of mentally being upset rather than just physically, because if your eyes started streaming, other people come and help you out and make you feel better.
How would that fit in with other animals?
I don't know of any other animals that cry for emotional reasons. The only reason I can think of for crying the way that we do when we get upset is essentially for the benefit of other people around us, so as they'll come and help us.
And also, with you saying about the blood thing as well, if you cry an awful lot, then your eyes are very, very red.
That's true.
Thank you very much indeed, Alan.
Okay.
Thank you. Take care. Bye.
Cheers.
Bye.
Bye. Hello to Andy in Huntingdon. Wants to know how fast a lead pellet would travel and how far if fired from a high-powered air rifle of 50 pounds pressure. Dr. Dave, over to you.
Well, this one is one which is basically, it's very dependent on all the sort of specifications of the rifle, how big the bore is of the rifle, how long it is, things like that. So basically I've made up a load of numbers and I can explain to you roughly how you would work it out for your particular rifle. Okay, so if I'm guessing by 50 pounds pressure, you probably mean 50 pounds per square inch of pressure. So if you work out how many square inches the back of your rifle bullet is, you can work out how much force that will push the bullet out at. So maybe if the rifle was 1/6 of an inch across, then it's going to be about 36 or 40th of a square inch of the actual area in there.
This is complicated.
So maybe it's going to get force of about 1.5 pounds of force on the bullet as it fires, which is about 3/4 of a kilogram. And if the bullet weighs a couple of grams, then it's going to be accelerating at about 300 metres per second. So if it accelerated at that rate for a second, it would be going at 300 metres a second, which is about 500 miles an hour. However, you'd need a very, very long gun for that. So you probably, if you only got a metre of gun, it's probably going to come out at about sort of 25 metres a second. If you shot that up at 45 degrees, it'd probably go about 80 metres is my estimate. So I think if you change, depending on your gun, if you had different weight pellets, different areas of the bore, different size of the bore of the gun, you'll get different results out of that sort of calculation. But yeah, it's basically a case of finding out how much force there is on the bullet, how quickly it will accelerate, and then how long it has to accelerate.
Crikey, rather you than me. The lightning brain of Dr. Dave. How do clouds float, says Mike in Peterborough.
Actually, this pretty much the same way as a hot air balloon floats. A cloud is made up of lots and lots of little tiny droplets of water. Tiny, much too small to see until they've turned into rain, of course, until they grow and form into big droplets, at which point they turn into rain and they fall out of the cloud. But mostly clouds are very, very small droplets of water with air in between them. And they're normally clouds form when you get hot air rising, and hot air rises because hot air expands when it warms up, which means that the same weight of air takes up more space, so the air gets less dense, and if something's less dense than the air around it, it will float. If you put water, which is less dense than water, if you put wood, which is less dense than water, into a lake, it will float. So you've got this warm air which floats upwards. As it rises, it cools down a bit, and the moisture in it tends to condense and form little droplets. But the air around, in between those droplets, tends to be a bit warmer than the cold air around it. And also, there's probably more water vapour in the air in the cloud than there is everywhere else, and water vapour is less dense than normal air, so that will tend to make it float. This is the same principle as how a hot air balloon, or in fact how a helium balloon, which you take home with silly faces drawn on it from the fair, same principle how they work. Basically, if you fill a hot air balloon, you heat up the air, it expands, it gets less dense, and so you fill up a balloon with it and you can float. Or a helium balloon, you pick a gas which is already less dense than air, like helium, and so you just fill a balloon with that and it will float. So basically, clouds float because they're full of warm, moist air, which is less dense than air, and they just float on the cold air around them.
After the overwhelming evidence from us, says Flymo, does the Doctor know or believe in UFOs?
Personally, out there somewhere, I could quite believe there are aliens. The universe is a very, 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 very big place. It's quite likely that there are aliens somewhere in it. It seems kind of strange if this is the only place where intelligent life has turned up. But I've seen no good evidence that the aliens have got here.
Brilliantly put. I reckon there's something hanging around out there, really.
But out there is an awfully big place.
Yes, exactly. We've got Tony in Westcliff. Dun, 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 dun. Hello, Tony.
Hello, Sue. Lovely to speak to you again.
And you as well.
Good evening, Tony.
Good evening, Dr. Dave. The sky, now it's blue, obviously.
Yeah.
But where does the blue start and finish? I mean, during the day, I saw the moon, but it looked white.
Yeah.
In other words, it didn't have a blue... if it had been blue between here and the moon, it would have looked blue, wouldn't it?
Depends on how the blue is getting there. Because you're right, if the sky was blue because it had like a big sort of blue acetate up in front of it, a big piece of blue, kind of clear blue plastic between us and the moon, then it would look blue.
Yeah.
But the reason why the sky looks blue is that when white light goes through the sky, it tends to hit sort of oxygen, nitrogen molecules and little bits of dust. And blue light tends to bounce off that more than other colours. So if you look directly at the sun, you see the white light. Not that you should do, because it's a very stupid thing to do. You'll see the white light with the colours which are about minus a few cuts, minus a bit of blue, which kind of actually gives you a yellowy colour. But if you look anywhere else, all you can see is this light which is bouncing off the atmosphere, basically, and that's sort of a weak blue light. Now, if the moon's behind that, the moon's quite bright white, and so there will be a bit of blue on top of that, but the white light coming from the moon will basically come straight through, and in fact it will have some of its blue light scattered out, so the moon should look slightly yellow, but with the blue light from the sky added to that, it'll look pretty much white. In fact, if you do a very, very long exposure photograph of the night sky, if there's a moon up, if you look at the sky, if you have a 5-10 minute exposure, so you can actually see the sky, and the moonlight will scatter as well, and so the sky looks blue even at night. It's just so dim that our eyes can't see it.
Good Lord.
I saw one of my friends has got some beautiful pictures of it.
It's intriguing. Incidentally, I should say this in about 3 words. What is piezoelectricity?
Piezoelectricity, basically that if you get certain crystals, like quartz crystals,
yes,
if you bend them, an electric charge will build up on one side, so one side will become positive and the other side will become negative. And so you can build up very high voltages like that. So the little the lighters which you get for gas fires,
Oh, yeah.
gas stoves, which you press the button and they go click and you get a little spark at the end of it.
Yeah.
What they're doing is they're bending a little crystal of quartz, and then one side becomes 3,000 volts positive, the other side becomes 3,000 volts negative. And then you have two wires going out to the end, and you get a spark between the two for the high voltage. You can the effect works the other way as well. If you apply voltage to a quartz crystal, it will bend. So
how does it bend?
But I think it's the reason why it's all going on is I think some parts of the basically you actually move. I think you're moving atoms within the crystal structure, sort of from one part, sort of just sort of one atom less than one atom space from one side to the other, which makes one side slightly wider and one side slightly shorter. And if you squash it, then it goes the other way. And so you can get little, very, very small speakers are often bits of quartz which you apply a changing voltage to, and they bend, and that produces vibration, and you can hear them. And other things which make ultrasound are normally made out of little quartz crystals like that. And clocks, digital watches, they often say quartz on them.
Yeah, that's I was just thinking that.
Used to, yeah. The way they keep time is they have a little tiny crystal of quartz, which if you apply, which will bend backwards and forwards a bit like a pendulum, if you put it in the right place in an electronic circuit. So this little piece of quartz will vibrate backwards and forwards. Actually, it's physically vibrating, but that's producing a little electric current going backwards and forwards, sort of tens of thousands times every second. And then the electronics in the watch counts that. And so it knows how many times it's wobbled, so it knows how much time has passed, and so it can write it up on the display.
Good Lord.
Wobbly crystals. Thank you very much, Tony. It's lovely to hear from you.
Bye-bye, Doctor.
What else have we got here? If men cut back big trees and where there was a nest, it's gone, and the parents keep sitting in a tree nearby, are they grieving, says Linda? You know, that's this sort of similar thing, isn't it? It's a kind of waiting or something.
I think there's the kind of instinct to look after children in many species is very, very strong.
Yeah.
And so basically the way nature tends to make creatures do things is it will kind of make them get a reward if they do something which they should do, which will mean that they produce lots of children. So looking after their children will give the birds a kind of reward. So it will give them some dopamine. And if you eat, you get sort of a reward because that makes you feel good. And if there's something which bad happens, then it'll sort of make you feel really bad so as you don't do it again. And so I'm guessing that that the birds are very, very very, very attached to their chicks, and it takes them a while and the kind of the deep part of their brain is kind of telling them they ought to be looking after their chicks. And when they can't find them, on some level it'll probably make them something analogous to us being sad, certainly.
Anyway, Peter from Wickford has rung to, if a duck's quack echoes, and if not, why not?
Yeah, I think there's a sort of story going around that a duck's quack doesn't echo. In fact, there's a guy who I've met a few times called Trevor Cox who actually did the experiment with a duck and found that it did actually echo. He does research on acoustics and things, and I think he thought, I think there's a story going around, you ought to do the actual experiment and see what happens. It does echo. All an echo is if you've got some, basically sound, if you make sound, it's basically vibrations in the air, a bit like waves on water, but in 3 dimensions. And if you have a water wave that comes up and hits the harbour wall or something, it will bounce off exactly the same way. If a sound wave hits any surface, pretty much it'll bounce off. If you've got sort of a lot sort of normal surfaces inside rooms or normal areas, there's lots and lots of little tiny echoes. So the sound will come out and echo a bit off the front of the car, a bit off the top of the car, a bit off the back of the car, a little bit off the next car. So it just comes back as nothing very particular and just sort of general noise and everything mixed up. If you get something not really nice and big and solid like a wall, and especially if you make a nice, short, very clear sound, you're able to hear that sound because there's lots of echoes all at the same time coming back, and you're able to hear a reflection of your voice. I think the only reason why he thought that a duck's quack people might think that, is that quacks don't really finish quickly, because you're able to hear an echo. You want it to kind of die. If it dies away really quickly, if you beep, you can always hear a ducks' quacks tend to sort of die away gently. It's hard to hear the echo because there's no silence after the noise, because it's the kind of quack. So there's no silence after the noise, so you can't hear the echo very well. But he's done the experiment and they do echo, I'm afraid.
If there are countless stars shining, why aren't the nights brilliantly lit up?
That's actually a really deep question. You're right. If the universe is infinite and there's stars sort of evenly spread over the universe, if you look in any direction for far enough, you ought to be able to see a star, and so the whole sky ought to be as bright as the sun is, at which point we'd all get frazzled. And that's actually very deep, and it tells us something very interesting about the universe. And what we think is going on, the reason why that is because the universe is expanding. And as the universe expands, the wavelength of the light will get larger as well. So the wavelength of the light is kind of getting stretched with the universe is one way of thinking about it. So if you look at something billions of light years away, so the light's been travelling for billions of years, which is right about the edge of where we can see, the light has been stretched sort of by tens of, probably millions of times. So instead of being, and so if the wavelengths get stretched, that makes it become redder and redder and redder, and it moves down the electromagnetic spectrum. So if you look, the furthest we can see is probably the cosmic microwave background radiation, which if you look in every direction, you see this kind of microwave radiation coming towards us, very, very cold microwave radiation. And we think that started off as gamma rays, so far beyond the blue, very, very energetic radiation. And then slowly, over billions of years, the universe has expanded, and that's moved from the blue through the red, through the infrared, and now through microwaves and into the microwave region. So the reason why the sky is black is because the universe is expanding, and the light has been so stretched that we can't see it anymore.
That's it for this week. Our doctors will be back with me next week for more Ask the Naked Scientist. But don't forget, you can also catch them on the Naked Scientist podcast, which you can find on the Naked Scientist website, www.nakedscientist.com.
The Naked Scientists are sponsored by the Wellcome Trust, the EPSRC and UK Fast. For more information, look us up online at nakedscientists.com.